Wow, what a wonderful day for a picnic.
Oh, look at those beautiful flowers over there. I am going to pluck some of them.
Hey, wait for me. I want to pluck some too.
Hello, children. What do we have here?
Hello, teacher. We have plucked 10 daisies, 4 hibiscus, 9 sunflowers, and 5 tulips.
They are beautiful. Do you know that you can represent the flowers you have both picked with a bar graph? Let us start by using squares to represent the number of flowers. If each square represents 1 flower, then 10 squares are used to represent 10 daisies, 4 squares to represent 4 hibiscus, 9 squares to represent 9 sunflowers, and 5 squares to represent 5 tulips. When all the squares are joined together, they become vertical bars like this. Can any one of you tell me what these 2 lines are for?
It shows here number of flowers.
The other shows types of flowers. But teacher, we do not know exactly how many flowers are there, and what are the types of flowers.
You are very observant, children. First, let me tell you the name of the lines. The one over here is called the vertical axis. This other line is called the horizontal axis. Now the vertical axis is showing us the number of flowers. Turbo Girl, do you know what is missing?
The numbers.
Clever girl! Let us add in the numbers now. Now Turbo Boy, what is missing on the horizontal axis?
The names of each flower.
Very clever. Let us add in the names now. It looks clearer now, doesn't it?
Yes.
Now a vertical bar graph is one way of presenting your data.
I know. By looking at the bar graph, I can immediately find the number of each type of flowers plucked by tracing the height of each vertical bar to the vertical scale. So, I can tell from the bar graph that there are 10 daisies, 4 hibiscus, 9 sunflowers, and 5 tulips.
Good work, Turbo Girl. We can also present the data on a horizontal bar graph just like this.
Do we always have to use a scale of 0, 1, 2, 3, and so on for the axis?
Not necessarily, Turbo Boy. We can use a different scale. For example, I can use the scale of 0, 2, 4, 6, and so on for the axis.
2, 4, 6. This is like the 2 times table.
Yes, this scale is in counts of 2.
Can I use the scale of 0, 10, 20, 30, and so on then?
Yeah, in counts of 10.
Yes, you can, Turbo Girl. We can write the scale in the counts of any number. However, we need to consider whether the scale is able to show your data clearly. Let's learn to read a scale properly. Look at this graph. What is the number which is missing?
It is in the middle of 0 and 2.
I know that 1 is between 0 and 2, so the missing number must be 1.
Well done! As you can see from the scale, 1 division is 2 units. If I were to subdivide that division into 2, now 2 divisions represent 2 units. So 1 division will represent 2 divided by 2 equals 1 unit. Take a look at the scale of this graph. It is a graph showing the number of children in a class who passed in each of the 4 subjects: English, Mathematics, Science, and Mother Tongue.
Each division on the scale is 10 units.
Yes, can you tell how many children achieved a pass in English?
Looking at the graph, the height of the bar representing the number of children who passed English is halfway between 30 and 40. Since each division represents 10 children and half of 10 is 5, I have to add 5 to 30 to get the correct number of children. Therefore, 35 children passed English in the class.
Brilliant! Both of you can read a bar graph effectively now. What do you have in your picnic basket, children?
Nothing much, just some sandwiches but lots of fruits.
Fruits. Can we have fruit salad for lunch? You can cut up the fruits while I go and get some yogurt from that shop to add to the fruit salad.
Great idea.
Wait a minute, children. Before you prepare your lunch, use a bar graph to show the number of each type of fruits which you are going to use for your salad.
No problem. Let's see. We will be using 5 apples, 20 grapes, 8 plums, and 16 strawberries. I can display the number of each type of the fruits we are using on a vertical bar graph like this.
Good job, Turbo Girl. Now, Turbo Boy, can you tell me, by looking at the graph, which type of fruit Turbo Girl is using the most in the salad?
At one glance, I can tell that the vertical bar drawn for grape is the tallest. So, Turbo Girl will be using the most number of grapes for our salad.
Very good, Turbo Boy. But remember to double check on the number. How many grapes are there?
Yes, 20 grapes.
Now, which fruit is Turbo Girl going to use the least in the salad?
The shortest vertical bar represents the apple. So, Turbo Girl is going to use the least number of apples in the salad.
Did you check the number?
5. Yes, it's the least quantity.
Fantastic, Turbo Boy.
Now, can I go and get my yogurt? I'm starving.
Just give me one more minute, Turbo Boy. I want to show the both of you how to make reading your bar graphs easier and faster. Always remember, each time you look at a bar graph, the first step you need to do is to find out the number corresponding to each bar, and then write the number on top of each of the bars, like this. By doing so, we can tell the number of each type of fruits very quickly. Moreover, we can find out other information without much confusion too. Turbo Girl, could you tell me which fruit is twice the amount of plums?
By looking at the number written at the top of the bar representing plums, I know that there are 8 plums. Twice of this number is 8 times 2, which is 16. Now, I will just look for the number 16 on top of the vertical bars. Here it is. 16 corresponds to the fruit strawberry. So, there are twice as many strawberries as plums.
Good work, Turbo Girl. Now, Turbo Boy, what about telling me which fruit is 15 more than apples?
That's easy. There are 5 apples. By adding 15 to 5, I get 20. Now, I just have to look for the number 20. There are 20 grapes, so there are 15 more grapes than apples.
Well done, children. Now run along and have your lunch. While you both were busy eating, I was observing a group of children camping at the other side of the park. The children were engaged in different activities. I have prepared the bar graph with the information I collected. Do you still remember what to do each time you begin looking for information from the graph?
We have to find the number of children for each of the activity and write its number above each of the vertical bars.
We also noticed in this graph that each division represents 4 children, and when subdivided into 2 smaller divisions, each smaller division represents 2 children. Therefore, there are 18 children who are cycling, 24 children reading, 30 children flying kites, 16 children playing badminton, and 8 children fishing.
Both of you are absolutely right. Now looking at the graph again, we can find out other information. For example, how many children were there at the camp altogether, Turbo Boy?
That's easy. I just need to add all the numbers up. 18 plus 24 plus 30 plus 16 plus 8. The answer is 96.
Very good. Now, Turbo Girl, can you tell me which is the most popular activity among the children?
Of course, the greatest number above the bar is 30. This number refers to the number of children flying kite. Hence, kite flying is the most popular activity.
Excellent, Turbo Girl. That was a very good and clear explanation.
Can I ask you a question, Turbo Girl? Can you tell me how many more children are there reading than fishing?
Let me see. From the graph, I can see that 24 children are reading and 8 children are fishing. I take 24 to minus 8 and I get 16. There are 16 more children reading than fishing.
I'm really proud of the two of you. Now run along and have fun. Let's recall what you have learned today. How do we read the bar graph below, Turbo Girl?
In a bar graph, the horizontal axis shows the different items which the graph is representing, and the vertical axis shows us the number of each item. I read each bar by tracing the top of it to the vertical axis to find the number. I then write it on the top of the bar so that I can refer to it easily for later use.
Do you still remember how to read the scale on the axis?
The scale shows the number of each item that the graph is representing in a certain multiplication.
Okay, how do you find the missing number, which is between two divisions, on such a scale?
I need to find how much is each division and then divide that by 2. I then add the number to the previous number on the scale.
Wonderful! You may go home now, children.
Bye, teacher.